Now, you might be curious how a linear model like linear regression is able to perfectly forecast the sine wave, which is clearly nonlinear. For those of you who are interested, I'd like to share with you the derivation, since I find this pretty interesting myself. If you are not interested, you can consider this optional, so don't feel like you have to understand this in order to understand the rest of the course. It turns out that it's possible to predict a sine wave perfectly using only two past values of the time series. We call this an AR2 model. Notice we do not even need a bias term. So let's see how this might be true. First, note that if you want to write a time series which is a function of time in mathematical form, it looks like this. So x of t equals the sine of omega times t. And yes, the letter inside the sine is omega and not w. The lowercase omega just happens to look a lot like a w. Now, if you recall, we actually did something very similar to this when we created the data. We said a series is equal to np.sine of 0.1 times np.a range of 200. So np.a range of 200 represents all the time points, and 0.1 was the angular frequency. Surprisingly, this is all we need to show that our AR2 model can learn a sine wave. Let's just plug in the sine wave function into our recurrence relation. By the way, recurrence relation is just a fancy way of describing the autoregressive model. The Fibonacci equation is also an example of a recurrence relation. In fact, it has the exact same form as our AR2 model with weights of 1. For this derivation, it's actually more convenient to shift the time steps up by 1. So instead of predicting x of t using x of t minus 1 and x of t minus 2, we'll predict x of t plus 1 using x of t and x of t minus 1. The next step is to multiply out the terms inside the sine functions. This still may not look like much, but let's keep going. The key here is to remember all the way back to your high school math, where you learned about trigonometric identities. Now don't worry, I've forgotten these as well. These are not the type of thing you use in your day-to-day machine learning work, so don't be too sad. The important identity is this one. It's the sine of a plus b plus the sine of a minus b equals 2 cos b sine a. Let's see why. First, we can manipulate our sine omega t equation by bringing the w2 term to the left-hand side. So now we have sine of omega t plus omega minus w2 times sine of omega t minus omega equals w1 times sine of omega t. Now here's the main trick. We have to recognize that both of these equations have the same format. If we look inside the sine terms, we see that omega t is just a and omega is just b. Immediately, this helps us figure out the constants w1 and w2. We can already see that w2 must equal minus 1. This also means that w1 is equal to 2 cos b, which is equal to 2 cos omega. Thus, we've proved that we can represent the sine wave as a recurrence relation.